Okay. Lifting condensation level is where, when you lift the air, it comes to a certain level in the atmosphere that everything condenses. Okay, this is when things condense. And I want to say lifting condensation level, aka cloud base. Let's make it more understandable. And LCL heights, when it comes to potential of seeing tornadoes, is actually very important. Studies have found that if you have high levels of LCL heights, then you have a lesser chance of seeing tornadoes. And I want to explain that to you right now, just kind of give you a little bit of meteorology here. You have to forgive me, this is actually a thunderstorm. And it kind of looks like a poor thunderstorm, but this is, okay, again, this is, say the LCL height is kind of like right here. And again, aka cloud base. And the reason why you really like to have lower cloud bases kind of closer to the surface is because if it's real high, what we have during supercell storms is that we have what we call a rear flank downdraft. The rear flank downdraft gets kicked out from the backside of the storm. And when it gets kicked out from the backside of the storm, it comes down to the surface. If it has a lot of dry air, because you have a kind of a higher cloud base, kind of dry air down here, the rear flank downdraft, I'll just call it RFD, because we love our acronyms. It becomes, what happens when the air, when you have evaporation, it's going to be the air parcel becomes cooler. Okay, so it becomes cooler and it's also become more stable. Okay, so, and what happens if this becomes cooler, more stable, what happens is part of this RFD gets pulled back into the updraft of the storm. And if this RFD is cool and stable, this updraft that's trying to produce this tornado actually becomes weaker. Because the updraft is weaker because this is actually more stable. All right. I'm a science officer, so I have to kind of explain a little bit of meteorology. All right. Okay, now we have a low LCL heights. The RFD punches down. You're going to have less evaporative cooling, so it's going to be warmer, and it's going to be more stable, more unstable. So it's going to be more warmer and more unstable. So it's going to be more unstable, more instability. So when the updraft comes in the storm, it doesn't inhibit the updraft, it actually maintains the updraft. So you have a better chance of seeing a tornado developing within the storm. That's the reason why, and that's what happened actually when George, Howard and I worked, what was it, back in 2002?
Somewhere along there.
Yeah, we had a whole bunch of supercell storms. It looked perfect like they produced tornadoes, and we had nothing.
They were textbook supercells.
Yeah, textbook. But that day, the LCL heights, the cloud bases were very high. I think they were, and what it did, it just inhibited the chance of seeing tornadoes developing. Okay, I'll move on.
And that's probably before we knew that much about the
Yes.
LCL height.
Yes, it is.
That's one of the more recent discoveries.
Dave would roll over every storm. He says, Howard, what do I do? I said, you have to warn. As classic of a supercell as this is, if you don't warn and anything happens, we can't explain it.
Yeah. But, okay, so we got instability. We have a boundary. We had LCL heights. I didn't show, but we did have LCL heights that lowered during the day. So we had good LCL heights. Okay, another key thing we all know about is shear. And that shear is actually what produces the chance of seeing the spin up within the thunderstorm. And one of the ways that we look at that, we look at storm relative helicity. So helicity values kind of tells the potential of seeing these rotations to occur. And I want to kind of zoom up in our area. You can tell we had values. Here's 700, 600, here's 500, 400. Generally, once you get, I'd say 150 to 200, you're in good environment for seeing tornadoes develop. So again, I'm trying to show you that when the forecasters looked at all this stuff, they sat down the radar, they had this ammunition that they knew that there was potential of seeing a pretty good outbreak of tornadoes. So we had a clue that if we see some rotation developing on these storms, they had a good chance of maybe producing a tornado. Okay, well, we also have other things we look at. This right here, I believe, as hell, we'll move on here. 'This right here is the significant tornado parameter. And the significant tornado parameter is a parameter that was developed by the Storm Prediction Center. Exactly, I don't know exactly who produced this one, but once you have values of 1 or greater, it just shows you a greater chance of seeing tornadoes. And let me kind of pull back here. Okay, this is pretty much when we had the Chattanooga tornadoes. And this is the time, right here is when we had, this is the time we had those Harrogate tornadoes that moved into Lee County. So, you know, one of the things we do during severe weather outbreaks, we generally have what we call mesoanalysis, some guy that keeps up with situational awareness. A lot of times George does that position. We also have other forecasters that do it as well. And what they'll do is continue to talk to, every once in a while, talk to the radio operators and say, these areas are becoming more and more conducive for producing, you know, tornadoes or whatever type of severe weather we're looking at. All right, let me move back to the presentation. All right, this is the last thing I was going to show you. This is, let me pull it up. This right here is a sounding. This is a sounding right around the Harrison, Tennessee area. And this is what we call a RUC sounding, or actually it's rapid refresh now. But it's just a model sounding of what the environment looked like in kind of the vertical profile. A couple things I'm going to show you real quick. One thing you can see is the winds. The winds kind of start out more of the south, the southwest, and they quickly turn more and more towards the west. So that's definitely an environment that's very favorable for shear. The hodograph, if you have a kind of a curvature of the hodograph like this, it also represents a situation that's conducive for tornadoes. I can kind of get into explaining the hodograph, but it'd be another 15, 30 minutes, and you don't want to do that. This is a storm relative helicity. It was that time, again, this kind of shows you represents of the spin in the atmosphere. It was right around 500.